Hello, friends. Today's lesson is about membrane permeability.
What in tarnation is membrane permeability?
Everyone and their mother knows that it's the process of molecules and ions moving through the cell membrane.
If cells are so small, how do we know how they work?
Well, not everyone can see cells, but lucky for you, I stole the magic school bus. So let's go! Here we are, the cell membrane. Well, you're on your own. A bunch of little kids owe me money, and it is payback time.
What the heck do I do?
I'm an expert in cell membranes.
Were you just hiding there the whole time?
Maybe. The cell membrane is made of a lipid bilayer, the hydrophilic heads and the hydrophobic tails. We refer to the molecule like these as amphipathic. The fluid mosaic model is a mosaic of protein molecules bobbing in a fluid bilayer of phospholipids.
I have no clue what you just said.
Don't care. The phospholipid bilayer has embedded proteins within it. There are integral proteins which penetrate the hydrophobic interior of the bilayer and the peripheral proteins which are loosely bound to the surface of the membrane.
Okay.
Did I say I was done? Cells recognize other cells by binding to molecules often containing carbs. They are called glycolipids or glycoproteins.
What am I supposed to do with this information?
I don't know, I'm just reading the script that Dorian wrote.
At long last, I have found my nemesis in cell membrane expertise.
No, he found me!
I can teach you more about membrane structure.
Did you just stab him?
Don't worry about it. Cell membranes are selectively permeable, meaning only certain things can go through. For example, hydrophilic molecules are blocked by the hydrophobic carbon tails of the bilayer so that they pass through slower, or sometimes not at all.
Bro, call an ambulance or something.
But hope is not lost for these poor hydrophilic molecules. Transport proteins allow these molecules to avoid the bilayer and pass through. This process is called facilitated diffusion.
I'm getting out of here.
Welcome to the school bus, so you're stuck with me. Another common transport protein is alkylphosphorin. This allows for the very polar molecule of water to enter the cell.
Got all my money back. Wait, Ziggy, how the heck did you get out of my dungeon?
You'll never take me alive.
I just want to go home, man.
Well, before you can go home, you have to learn about passive transport. Come with me to my dungeon. Home sweet home. So, diffusion is just the movement of particles so that they speed out into available space. A substance diffuses down a concentration gradient, the region along which the density of a substance increases or decreases.
Man, I'm thirsty. Do you know where I can get some water?
Funny you mentioned water. The diffusion of water across a selectable permeable membrane is called osmosis. Water moves from an area of high water concentration to a low water concentration.
You got any Doritos?
Doritos? Doritos have a high solute concentration. If you place a cell in a high solute concentration, it will shrivel up and become hypertonic. If there is too much water going into the cells, then it becomes hypotonic and bursts. If there is no net water movement, the cell is stable or isotonic.
Wait, so how do fish live in salt water in the ocean?
Improvise, adapt, overcome. Cells use osmoregulation to adapt to non-isotonic environments. But sadly, organisms are not invincible. Plant cells can go flaccid, turgid, or they go through plasmolysis, which is where the plants wilt and die.
So, vegans aren't the only thing killing our gardens.
5 minutes later.
Ha! I'm back.
What? How did you survive?
Because my cells use active transport. Active transport is where the cell uses energy to pump solutes across the membrane against the gradient.
Impossible.
Active transport enables a cell to maintain internal concentrations of solutes that differ from the environment. It uses ATP to accomplish this.
Give me an example then.
Easy. The sodium-potassium pump exchanges sodium ions for potassium ions across the plasma membrane of animals. But that's not all. Ions have an electrical gradient too. the electrical gradient and the concentration gradient and combine to form the electrochemical gradient, which determines the direction.
Your knowledge of membrane permeability is impeccable.
I know, my father taught me. He would be proud.
No, Danush. I am your father.
No!
Guys, hello.